Friends, and welcome to the Math Magic Show. In this one we're going to take a look at the mystery of finding the derivative of the tangent inverse of x function. And the mystery is all these crazy steps here. Anyway, let's get going. So we're going to begin with step number 1, y equals tangent inverse of x. The key, or a key to this process, is to recognize that the x that you see here is really x over 1. Why does that make a difference? It makes a difference because then we have this triangle, and this x in the numerator, that becomes the vertical leg, and the 1 becomes the horizontal leg, you see? Therefore, by the Pythagorean theorem, as always, 1 and then x become here the square root of 1 plus x squared, as shown, this length right here, the hypotenuse of the triangle. Now, take a look, go back to step 1, y equals tangent inverse of x. So if you apply the opposite operation, you would have that tangent of y is equal to x. Just basically take the tangent on both sides, right? So this becomes tangent of y, and the tangent of tangent inverse just gives you the x back. So you've got this step 4 now. Now look at this. Tangent of y equals x. This y that you see right here, it's really a function of x. What does that mean? What it means when you go from 4 to 5 is you have to do implicit differentiation. So the derivative of the tangent is secant squared, you copy the y, and then you got to multiply by the derivative of the y with respect to x, because that's an implicit derivative. And the x gets differentiated as shown here. That takes you to step 6, where it says secant squared of y times dy dx equals positive 1. So the derivative of x with respect to x is 1. You keep this part. Take a look at the next stage. So step 7 here. Just take step 6 and divide both sides by secant squared of y. So I've done that here. So dy dx equals 1 over secant squared of y. Now, a bit of reminder about notation. Hold on, I got a tug on this cord here. So secant squared of y is going to give you 1 over secant of y, that whole quantity squared. Why is that relevant? Take a look. So using this triangle, the secant of y is hypotenuse over adjacent. So the hypotenuse is the root of 1 plus x squared. The adjacent side, given the angle is this angle right here, is the 1. So you have the root of 1 plus x squared over 1, which then just simplifies into the square root of 1 plus x squared, as shown right here, right at the last step of step 8. But now, what does that mean? Well, go back here for a second. This is 1 over secant of y squared, but now we know secant of y in terms of x is 1 plus x squared under the root symbol. So I can write dy dx, taking step 7, and I'm just going to replace secant y right here with the square root of 1 plus x squared from this step right here, from step 8. And I have the little 2 here. That 2 is the same as this 2 up here. But of course, what do we do next? Well, now the 2 here and the root cancel off, their inverse operations. And at step 10, friends, we have dy dx equals 1 over 1 plus x squared. In other words, what we have just proven is that when you differentiate the tangent inverse function, that derivative is 1 over 1 plus x squared. That's what we have just proven by using all of these steps. That is it for this one. Math is a bit of a mystery, as you can see. It's really beautiful if you think about it, how all the steps connect, how this all snaps together in such a beautiful, cohesive picture. Leave a like, please subscribe, please share this video, leave some suggestions for future videos, and I will see you in the next one.